Welcome to this class. For this session, we want to do some more examples on implicit differentiation. The first problem is to determine the slope of the tangent line to the graph x squared plus 4y squared equals to 4 at the point root 2 minus 1 over root 2. Solution. So first apply d dx. This is usually the first step on implicit differentiation. Now, after supplying d dx, now get the derivatives. So here we'll get 2x by power rule. Here we get 8y, but because it's a y, we attach dy dx. And then this other side will be 0. So divide through by 2, we have, or before dividing through by 2, just say 8y dy dx equals to negative 2x. And to get dy dx, divide through by 8y by 8y, so that dy dx is negative x over 4y. Now, the problem was to find dy dx, or the slope, at the point root 2, comma minus 1 over root 2. So this means we'll have negative root 2 over 4 times negative 1 over root 2. So which is root 2, negative, negative, positive, and then 4 over root 2. Now, when you have root 2 divided by 4 over root 2, the same as root 2 times the reciprocal of root 2 of over root 2 is the same as this. So this will be root 4 over 4, which is 2 over 4, and this will give us a half. So that is the slope of the tangent at that point to that given curve. Problem 2, find dy dx given that y cubed plus y squared minus 5y minus x squared is equals to minus 4. So here you just supply d dx on every term as the first step. So d dx of y cubed plus d dx of y squared minus d dx of 5y minus d dx of x squared equals to d dx of minus 4. Now here, by power rule will be 3y squared, but because it's a y, you attach dy dx, plus here will be 2y, but because there's presence of y, dy dx, minus 5y will give us 5, but because this y, dy dx, this will be just 2x, and this is 0. Derivative of a constant is always 0. So we'll have 3y squared plus 2y minus 5 dy dx equals to 2x. So which means to get dy dx, we simply supply through this factor of dy dx. So divide through by 3y squared plus 2y minus 5. 3y squared plus 2y minus 5. So this bracket and this bracket cancels out. So the answer is 2x over 3y squared plus 2y minus 5. And then next one, we have this number 3, given that x squared plus y squared equals to 5, find the second derivative. Now, we get the second derivative after finding the first derivative. So, solution, first supply d dx plus d dx equals to d dx. Then d dx of x squared is 2x plus 2y, but dy dx must be attached to it, equals to 0. So this means dy dx the same as negative 2x over 2y, get the same as negative x over y. So you let this one to be u, this one to be v. So it's u prime v minus v prime u over v squared. So v prime is negative 1 times y, v is negative y minus v prime is dy dx times v. So minus minus plus. So we'll have x dy dx divided by y squared. So which will be negative y over y squared plus x, but dy dx we put minus x over y divided by y squared. So which is the same as minus y over y squared minus x squared over y squared. So x squared over y divide y squared is the same as x squared over y times reciprocal of y squared. So it'd be x squared over y power 3. So this is the same as minus y over y squared minus x squared over y power 3. And you see we can put this over y power 3. So this will be negative y squared minus x squared equals to d squared y dx squared, which will give us, can factor out negative and then say x squared plus y squared over y power 3. But from the problem, x squared plus y squared is 25. So write this one as minus 25 over y power 3. So that's how we solve those problems.